Hi again. So this is why today we're gonna have a lecture on chapter one for the belt drive transmissions. Anyway, this is gonna be the content for the final examination that we're gonna set for. So let's go for it anyway. That what it said in here: belt bolts, chains, and other similar elastic or flexibility machine elements are used in conveying system as in the transmission of power or comparative long distances anyway. So this kind of thing we're gonna talk together about chapter one and chapter two. Typically, we have some kind of like two parallel shaft anyway for the input shaft and the output shaft, things like that. For instance, like we have a motor to drive a pump, put in the manners of parallel shaft anyway. We typically consider about the belt drive transmission, either on the belt drive and or for the chain transmissions anyway. We're gonna talk about it later anyway. So that's why typically belt drive is going to be the first thing that we're going to consider with anyway, because it's going to be very cheap stuff. We're going to think about it first anyway. Okay, so let's see for the advantages of belt over chain transmissions anyway. As you may figure out, if we have two kind of power shaft driving the other shaft, things like that. Okay, we're going to have number one, absorption of shock load, of course, right? Okay, then what we are mechanical engineers, we face a lot of vibration and stuff like that. One way or another, then, so the belt can absorb the shock loads and vibration typically. And then it's got to go number two, isolate the effect of vibration. They were talking about it already. And then number three, slower cavity course. Of course, you pay just less money, but you get very effective things, things like that. And then easy to operate, of course, right? It's not so complicated. And then number five is going to be low associated noise emission. In a way, it's got low noise in a way compared to the belt, things like that. It's got a lot of contact between the metal to metal, things like that. And number six, being able to turn power or complete long extended distance. It's the most important thing that what we can, if we have a pretty long center distances, things like that, we can think about to use the belt drive transmission, of course, right? So if we choose a chain, things like that, it's gonna be heavy, things like that. And number seven, of course, not so complicated. It's gonna be low and maintenance course anyway. Okay. So let's see for the disadvantages over the chains drive anyway, because it's why see if you compare to the chains, the synchronous manners anyway. Number one, slippage may involve during transmission, of course, right? The belt gonna cause some kind of like a slippage, both in terms of the pulley drive, okay, or the human pulley or driving pulley, things like that. We're gonna talk about it later, anyway, okay. And then if you compare to the chains, it never ever happened for the slippage at all. Okay, this is one of the good things for the chains in a way. And number two, creep of the belt may involve. So creep is some kind of like a permanent elongation. If used for a long time, things like that, the belt experiencing just elongation, things like that. So this creep, because of course the belt should be adjusted most of the time, things like that, to adjust for the belt tension, to avoid for the slippage, you know. Okay? And number three is gonna be a speed ratio cannot be constant during the belt slippage. Of course, right? Because slippage, the speed ratio won't be constant anymore. It's going to vary the slippage anyway. And number four, initial tension in belt is necessary. Okay, I want to talk about it. If we don't have the belt to be strong enough or to be tension enough, it's going to cause a slippage, of course, right? And number five, inefficiency to be used with the high speed ratio. The speed ratio of the belt transmission should be less than 5. This is kind of one of the things about the limitation of the belt transmission system, things like that. Okay, and then let's go over for more details of the belts, things like that. Typically, we're gonna have four type of belts in a way in motion, in transmission, things like that. Number one, of course, is gonna be very simple and very not very complicated flat belt. Okay, it's typically gonna use in less in the not so for sophisticated machinery, stuff like that. It's typically used in terms of rice mill. In Thailand, a lot of rice mills going to be happening for the old-fashioned one, things like that. We're going to have a lot of fat belt okay, all over the places, things like that. It's going to drive effectively, not too very fast in terms of for the speed or the belt speed, things like that. That's why you can apply for the belt drive, things like that. And the one for the round belt is gonna look like a rope, things like that. It's not quite popular. It's not quite we use a lot, but most of the time, sometimes we're gonna use it agriculture machinery, things like that. Okay? And number three, rebuild is going to be most effective to transmit the powers, things like that. If we think about the rebuild, things like that, we think a lot. We apply for automotive engineers, things like that. Okay? And number four, also the timing belt is going to be look like similar to the chain drive transmission. It's going to avoid the slippage, things like that. It's going to be very good. But one way of another disadvantage going to be it's going to be have some lifetime, things like that. So that's why the creep gonna happen, things like that. So that's why if we use for a long time, we're gonna change it, things like that, to avoid the creep, things like that, or some kind of damage on the belts, whatever. Okay. So therefore, okay, let's see for the figure. You're gonna get some idea about characteristics of some common belt drive. That what I put down in this kind of table. You may see the first line there, gonna be flat belt. The figure gonna be a square cross section, things like that, or some kind of like a rectangular shape, things like that. And the joint, okay, over the open and the rear end, things like that. You're gonna have a joint to each other, things like that. And the size thickness is gonna be from 0.75 to 5 millimeters. And the center distance is no upper limit. So it's why as long as possible, things like that. Okay, you can apply it on it anyway. And then the round belt, things like that, very similar to the flat belt. It's gonna be round all the way for the cross section, things like that. And for the V belt, things like that. See, the V belt's gonna have a shape pretty much look like that. So therefore, the V belt's gonna have the center distance is gonna be limited, things like that. The most effective thing we're gonna talk too much about it anyway. And then the last one is gonna be timing belt. It's gonna be look like a chain, things like that, but it's made of rubber impregnated with some kind of like fiber, things like that. Most of the time, kind of talking more details about it also. Also, the timing belts are gonna have a limitation in terms of certain distance, okay? And then for the belt manual, okay, then what I typically would like to let you guys know about the belt are typically made of material that obtain high tension strength and high coefficient of friction, such as that can be able to will withstand with twisting load. Okay, this is one of the good things that what we're gonna consider about the belt, the material to be applied for the belt, like that. Okay, so let's see for the first one for the flat belt, that what is said in here. The flat belt are typically made of urethanes and also the rubber impregnated flap reinforced with steel wide or nylon cord to take the tension load, things like that. I would like you guys to understand about the rubber impregnated, things like that. Okay, so therefore it's like a sandwich together, things like that. See, we have a fabric in between, and we have a rubber, and then we just apply some heat on it. It's gonna cover all over the fabric, things like that. Okay, or either for reinforced. Okay, that's what we apply the steel. Okay, lining. Mage, things like that. So also we can do that. Okay, we apply for this kind of thing. See, this kind of thing is going to be rubber impregnated, the keywords on it anyway. So therefore, okay, the V belt, okay, that's what is said in here. That's what I talked to you guys already, right? We're gonna emphasize in terms of the V belt because it's what we're gonna use a lot, okay, for the transmission system very effectively. Uh, a V belt is made out of fabrics or core, usually got to be made from cotton rayon or nylon and impregnated with the rubbers again. See, that's what this is the thing that what we're gonna do on it. In contrast with the V belt, the flat belt V belt are used with similar sheath and shorter center distance. Okay, now what you guys gonna think about the sheath here? The sheath is gonna be the pulley anyway, the same things anyway. So sheath is mean you have between two sheaths anyway, or shoot two pulley for the driving pulley and the driven pulley, things like that. Okay, so that's why the center distance is gonna be short, things like that. Okay, when you apply for the V belt. And then let's see for the timing belt. Okay, set it here. The timing belt are made of rubberized fabrics and steel wire and have teeth, okay, with fit into groove cut on the furry in the furry of the sprocket, things like that. Okay, so that's why they think this kind of thing used a lot with the timing belt, things like that. It driving between the crankshaft and the camshaft in the engine, in the combustion engine, things like that. Internal combustion engine, things like that. Okay, we're gonna use a lot of this and way from really updating material, things like that. Okay, one of the good things that what I put on the bracket here is gonna be the things that what we just put in mind as we're gonna have design for the belt to be transmitted between two shafts anyway. For safety factor of the belt should be around 10, things like that, because that's why if you apply for the high speed, you're going to consider about okay the damage of this. Okay, coefficient of friction of the leather belt is going to be 0.4 up to 0.5. For the rubber belt, it's going to be 0.3 up to 0.4 respectively. And the speed of the belt recommend to be 1,000 to 2,000 meter per minute or 16 to 30 meter per second, things like that. Okay. And then let's see for the pattern of the belt drive. Okay. Number one, okay, you're gonna figure out 1.1 and 1.2 respectively. 1.1 is gonna be an open drive, things like that. See the small pulley we're gonna call is the driving pulley, things like that. And then the driven pulley is gonna be on the right hand side. Okay, so this one gonna rotate in a clockwise direction. So the both of them is gonna be rotate in a clockwise rotation as well. So therefore, in this kind of sense, see, you may figure out the down and the belt here is gonna cause tension, okay, and then it's gonna be in the the top parts of the belt in motion is gonna cause some kind of loosely, things like that. So that's why we call it tight side, okay, under, and then the loose side is gonna be on the upper side, things like that. Okay, you may think it over because when this drive, this one is gonna be very tension, and then this one is going to release a little bit, so it's like the sag, okay, going to be happening at the top parts. It's what we call here is going to be tight side down under, okay, the loose side is going to be on the upper side, things like that. Okay, so therefore in this kind of sense anyway, okay, in figure B here is driving on the opposite direction. Okay, of course, okay, the driving pulley is going to be a small one right here, and then the driven pulley is gonna be driving in the same direction. It's gonna clockwise manners. So therefore, on the upper belt, we're gonna experiencing a tight side, right? And then the down under is gonna be the loose side, right? So typically, to increase the for the coefficient of frictions, anyway, we're gonna apply the either or jockey. Sometimes we call it either or jockey, whatever, on the loose side, okay, to increase more contact angle between the belt and the pulley. Okay, can imagine here, okay, if without the either here, so this way the angle going to be small of contact. If you apply for the either on this kind of manners, okay, so the angle is going to be more, okay, of contact, okay, on the belt between the belt and the pulley. So therefore, one way or another, that will be increased, okay, for the efficiency of the belt drive transmission system. Or we just reduce the slippage anyway. Okay? So we're gonna apply the iders on the load side most of the time. And then this is gonna be the open drive. You may figure out, okay, the pulley, okay, the driving pulley and the driven pulley gonna rotate in the same direction. We got open drive. Okay, and then another one we have in figure 1.2 for the A1 here, we have a cross drive. Okay, in this kind of sense, you may figure out that the driver and the driven is gonna driving in the opposite direction, just like that. Okay, in figure A respectively. For figure B, see we have so many drive things like that. We have one drive and we apply for another driven pulley things like that too. In figure B, we call it the reverse drive. Okay, and figure C, okay, the shaft can be able to be perpendicular to each other. Okay, you may figure out figure C here. We have two pulley there. One is centered down there. Another one is centered down there. So therefore, this kind of shaft perpendicular to each other, we can apply like this. Okay, so therefore, this kind of thing, okay, we can call it the figure C is called the turn drive. Okay, another one is mule drive. Okay, there we can apply the tool. It look like that too in figure D. The shaft is perpendicular to each other. We apply the jockey there to be able to make a mount drive for that. Okay, a lot of things have been applied, a lot of this with the machinery, okay, for the driving system between the two shafts. Anyway, okay, and then let's see the force, okay, associated with the motion of the belt drive transmission system. Anyway, okay, let's see if in figure 1.3, okay, on the open drive and the cross drive respectively. Okay, let's see for the open drive first. Okay, we have a driver there, we have a driven pulley there. So therefore, of course, down under F1 is got to be greater than F2 during the motion anyway. You agree on that? Because that's why, see, when we start some motion, if we stand still, F1 and F2 equal to each other. Okay? And then when we start the engine, whatever, okay, the driver got experiencing to pull, okay, the belt. So therefore, F1 going to be greater than F2 then. Okay? So therefore, F1 is greater than F2 during the motion, things like that. Okay, and you may see a figure out there. The alpha one and beta one is show you up there, and then we have alpha 2 and beta 2 respectively. Okay, so therefore, okay, let me go for this anyway. Okay, in figure 1.3, that what I said here, okay, illustrate the open belt drive and the cross belt drive transmission. Accordingly, the corresponding parameters of the open drive in figure 1.3a and cross drive in 1.3a can be summarized as follows anyway. In figure 1.3, let's see the alpha 1 can be determined in terms of radian. Look like that. And alpha 2, you got to remember the subscript 1 is stand for the driver, and number 2 is going to be the driven one, respectively, and beta. Okay, let's see the figure there. Beta can be able to determine on that the length of the belt. Okay, from the first point up to the last point. Okay, we can be able to look like that. Okay, so this is the equation that what we can be able to use this kind of equation to mean for the open drive system anyway. And then let's see for the cross drive there, we have only one alpha there, and alpha there is the same thing. That's what we got there because it's cross, right? So therefore the angle of contact can be equal to each other then. So therefore we have only one alpha and beta respectively, and the L is going to be the length of the belt. That's what we've got there. Okay. Then what I put in there says C ascending distance. F1 is going to be tight side, F2 is going to be loose side, and D small is going to be the diameter of the small pulley, that's what we call the driving pulley. And the capital D is going to be the diameter of the large belt. Okay, and N1 is going to be the speed of the subscript 1 stand for the small pulley, and N2 is going to be large pulley, respectively. M is going to be the mass per unit length, and W sub P is going to be transmitted power, and mu is coefficient of friction between the belt and the pulley, and F1 is going to be initial tension in the belt, and then alpha contact angle of the belt and the pulley in terms of radian, and L is going to be of length, and S is percentage of slippage, and small v is going to be belt velocity. It's like that. So therefore, the initial tension force F1 can be able to you look like that. F1 equal to F1. I'm sorry. Fi is going to be equal to F1 plus F2, so what to that's what we call the initial tension force. Anyway, in the belt. So therefore, this one, okay, I explained already. Okay, during the motion, okay, F1 typically going to be greater than F2, but if it's a standstill, everything's going to turn to be F1, Fi respectively. Okay. So therefore, the torque, okay, for the small pulley can be able, if we just take a moment down to the center of the pulley, we're going to have F1 minus F2 over time D over 2 respectively. For the large pulley, it's the same thing, okay? We're going to F1 minus F2 times the capital D's over 2 respectively. So therefore, the transmitted power is going to be the torque time the velocity, right? So therefore, we're going to have the power going to be F1 minus F2 times V. Okay, with V, it's going to belt velocity is going to be either pi d times n1, pi d, the capital D times n2 respectively. And then the relationship of F1 over F2 is going to be e to the power of mu times alpha 1 when alpha 2 is greater than alpha 1, or either if alpha 1 is greater than alpha 2, we're going to have this equation respectively. This is going to be the relationship of F1 and F2, okay, in the logarithmics equation, looks like that, okay. Then what is said in here, okay, I will read it too for you, anyway. The determination should be done at the various slippage may occur. When alpha 2 is greater than alpha 1, the slippage may take place as a small pooling. Therefore, equation should be employed. Okay? In a similar manner, if alpha 1 is greater than alpha 2, it means the slippage may take place at the large pooling. Okay? The subscript number 2. So therefore, okay, equation should be applied. Okay? And then, okay, search for the cross belt. No doubt about it. Alpha 1 equal to alpha 2 equal alpha. So the equation above turned out to be F1 over F2 equal to e to the power of mu times alpha respectively. Okay, and the F sub c, okay, that's what we have got there. It's going to be centrifugal force m times v squared, which is put down under for the mass is going to be e to the w over g, things like that. So this way equation is going to be look like that. So therefore, if we think about the centrifugal force, we gonna make deduction from the F1 as F2 respectively. So that's why the above equation can be modified. If we consider about the Fc for the centrifugal force, it turned out to be look like that respectively. And for the force drive, if we consider about the F sub c, turned out to be look like that. And the speed ratio, okay, we talked about it already, should be not more than 5. If you don't believe it, if you just apply more than 5, it's going to be easily course a slippage. Look most likely at the driving pool lane, okay, typically, okay. And then, so therefore, the speed ratio with slippage can be able to determine for S is going to stand for the percent of late slippage. It's typically approximate to be 2% anyway. So therefore, this is the thing, okay. So now let's go for the things that what we're gonna talk about it, okay, for the fat belt type system. We have two things that we're going to discuss in more, the fat belt and the V belt. Okay, so let us stop it for a while, and then we're going to consider about the 5.2 respectively.